Okay, so here in this video, I'm going to solve a vector word problem in two different ways. One will be purely by a triangle via law of cosine, law of sines, and the other method is by vector addition and using components of vectors and all that. Okay, so let me first start with the pure trig method. Okay, I thought this was interesting because I started solving this problem using the vector component method, and then my student got very confused because in class, she learned to use law of sine, law of cosine to solve these vector word problems, which I think is much more tedious than the other method, okay, and totally unnecessary, and doesn't teach you the concept of vectors and breaking it down to its x and y component. Get it? You can add vectors together and then finding the magnitude of that resulting vector and the angle of that resultant vector and all that. This triangle method doesn't teach all that, I feel like. Okay, so anyway, let me solve it. Okay, so the problem is number 4, a ship sails for 50 miles on a bearing of 165, then turns and sails on a bearing of 220 degrees for 35 more miles. How far is the ship from its starting point? What bearing would the ship need to head back to its starting point? Okay, so a good idea for these word problems is to draw out what's happening. Okay, so let's say that the ship started up here. Okay, up here. Okay, so it went on a bearing of 165. So bearing is with respect to the positive y, the North Pole. We go clockwise. Okay, so I marked in black here. That's bearing, that's angle 165. So it's gonna go this way for 50 miles. And then it turns and goes for 35 miles on a bearing of 220 degrees. So once again, I draw a representative axis here. Bearing, once again, is with respect to the positive y. So this angle in black again is 220 degrees, okay? So it goes this way for 35 more miles. And the problem asks us how far is the ship from its starting point. So we're asked to find this blue line D. What's this length? Okay, so we have two sides of the triangle. Okay, and they don't give us this angle yet, so I need to cover that up. So we have to find it. If we can find what this angle is, then we can use the law of cosine to find out what D is, okay? And actually we could find out what this angle is if you have to be really good at visualizing and seeing which angles are congruent and all that, okay? Which is why I don't really like this method. I feel like people will struggle more with this method. Okay, so since I drew this like plane again over here, I know that's, well, this horizontal line here is parallel to this horizontal line up here, okay? This angle over here is the same as this angle over here. They're congruent, okay? So because those lines are parallel, okay? Now I know this angle over here is 75 degrees. How do I know that? Well, from the North Pole to the vector here, or this side here, this isn't really a vector. So like, once again, I don't know why they're teaching this, doing a vector word problem with this method and not vectors. But anyway, back to the problem. We have this angle, which is, what was I saying? So from the North Pole to this side of the triangle, that's 165. From the North Pole to the x-axis is 90. So how much more do we have to go from 90? That's just 165 minus 90, that's 75. Okay, so I know that this angle is 75 degrees. And so this angle is also 75 degrees, okay? We could do something similar for, actually, we don't need to do something similar because I know that from the positive x here to the, positive y here to the negative x here, that's a total of 270 degrees. So from the positive y to this side of the triangle is 220. How many more degrees do I have to go to get to 270? That's just 50 degrees, okay? So this side of the triangle is 75 plus 50 degrees, which is 125 degrees. So now that we know that, we can use the law of cosine. D squared is 50 squared plus 35 squared minus 2 times 50 times 35 times cosine of this angle, which is 75 plus 50, or 125, right? Plug this onto your calculator. You should get D is 75.7 miles. Okay. And then after that, since we have one of the sides, we can find like all the other angles of the triangle, okay? Either with law of sine or law of cosine. Law of sine's down here, law of cosine down up here, okay? So the second part of the problem asks us, did it get cut off? The bearing. So if the ship is here, the bearing to go back up here would be this angle I marked here, theta. That small angle there. Okay? So if this is theta, this is theta. Why is that? Well, again, you have to be good at your geometry. This vertical line is parallel to this vertical line. So this angle is congruent to that angle. Okay? And actually, let's mark this angle theta plus 15. How did I get 15 here? By the way, well, I don't think I mentioned that yet. Well, from here, the positive y to the negative y, that's a total of 180 degrees. So we already went 165 from positive y to this side. So we need to go 15 more degrees to get to the negative y, or 180 degrees from the positive y. Okay, so that's how we get that. See, this is where all these keeping track of them, calculating them, it's tedious, which I don't like this method. Okay, so if once again, I was saying, let's let this side of the triangle, this theta plus 15, let's call it some other variable like alpha. We can use the law of cosine again to find what alpha is. That's here, I won't go through the steps. You should get alpha is 22.27 degrees, somewhere around there. But we found alpha, we want theta. So theta is just alpha minus 15. That's 7.3 degrees-ish, okay? You can similarly do law of sines. Sine alpha over 35. This is alpha, so the corresponding side is 35. That ratio is the same as this angle, which we know, sine of 125, or 75 plus 50, divided by D, the corresponding side. Okay? You solve for sine alpha, which I guess I did not plug into my calculator, but in exact form, it'll be like this, 35 times sine 125 divided by D. And you should find alpha, once again, is 22.3-ish. And then after you find alpha, you do the same thing that we did up here. We find theta, which is alpha minus 15. So you should get, since our alphas were the same, you'll get the same theta. Okay, so hopefully this made sense in this method. Now let me show you the other method, which is more intuitive. Okay. So on this piece of paper, I did it in vectors instead. Okay, so once again, let's review the problem. The ship goes one way first, and then it turns. So you can represent the first motion as one vector. So the first motion is with the bearing of 165. It went this way for 50 miles. So you can represent that as a vector. Let's call that V1. The second motion, it turned, right? We can call that motion V2. And it went 220 degrees. That's in blue. Okay, so what we're given is in blue over here. So we can call it V1 and V2. And we're asked to find how far the ship is from its starting point. Okay, so that's just this vector over here. And actually, we can use the same vector. So to answer both questions, how far is the ship from its starting point? What bearing would the ship need to head back to its starting point? Okay, so if it's here after the two motions, right? Then to head back home directly, you could just go like this. So we can draw that as another vector. Okay, so that's this black vector over here. Okay, all right, so hopefully that makes sense first as to how I set it up. Vector and a vector, and then to go home, that's another vector like that, okay? So basically, it's asking, when it asks us how far is the ship from its starting point, that's the length of this vector, v3, or the magnitude of this vector. So how can we find what v3 is? Okay, well, if you can visualize it, if you go from this way, not back home, but if you go directly from the starting point to where it is right now, so in this way instead, it's just v1 plus v2, the vectors, vector addition, okay? So how do we get V1 and how do we get V2? Hopefully you know this. It's the magnitude of the x component, or the I component, is the magnitude times cosine of the angle of the vector. And then the j component, or the y component, is magnitude times sine of the angle of the vector, okay? So what's the angle of the vector? We know what the magnitude is. They give that to us as 50 miles. What's the angle of the vector? How did I get this minus 75? Well, angle of vector here is with respect to the positive x, okay? So if the vector is going here, we can say that, well, with respect to positive x, it's negative 75 degrees, okay? Or you can say, if you want to go this way, it would be what? 360 minus 75 degrees, okay? That also is totally valid, okay? So just because we drew our picture like this, I know that, well, how did it, okay, let me review how I could get minus 75. Well, from the positive y to here is what? That is 165. That's what they give us, okay? From positive y to this positive x, it's 90 degrees. So how many more degrees did we go from 90 to get to 165? That's 75 degrees, right? Now, why is it negative? Well, remember when we talk about angles in trig, in polar form, it's going counterclockwise. Here we're going clockwise, so it's negative instead. Okay. Otherwise, remember I said earlier, you could do 360 minus 75 degrees. That's also okay. Okay. So that's how I got this angle. This would be V1, 50 cosine negative 75 plus 50 sine of negative 75j. Okay. V2, we do something similar. We know the magnitude, that's 35. How about the angle? Well, once again, they give us that from the positive y to this point here is 220 degrees. Now, we want to start from the positive x. So it's just 90 degrees less, right? We want to omit this first 90 degrees up here. So what's 220 minus 90? That's 130. And once again, we're going in the clockwise direction. So it's negative 130. Okay, so V2, it would be 35 cosine negative 130, I plus 35 sine negative 130, j. So V3 is, well, I think I said it earlier. If we go this way, not up here, but if we go from the starting point to here, it would just be V1 plus V2. But we're going to go back home. So I just add a negative sign out in front of V1 plus V2. Okay? So if you plug this into your calculator, remember how you add vectors? You add the x components together for I and the y components together for j. Okay? Or you could add the i's together, add the j's together, however you want to think of it. Okay? So that would give us 9.56i plus 75.1j. And this is really helpful that we got this because we can answer both questions now. Okay. And by the way, you can kind of visualize that this is correct because, well, to go back home, it should be pointing in quadrant 1 or something like that. And this is, okay? So the length of the vector, that's the distance. Okay. So that's just magnitude, which is the x component squared plus the y component squared. Okay, plug into your calculator, you should get 75.7, which matches what we got over here, right? And it should. All right, and then, how do we find the angle of a vector? That's just the arctangent or the inverse tangent of the y component and the x component, right? You got to be careful. Remember, the arctan only gives you angle in the first and fourth quadrant. But in this case, we're okay because this vector is pointing into the first quadrant. So whatever angle we get, we should be okay. And we get 82.75. So this angle, let's call it alpha, okay? It's once again with respect to the positive x. So it's this red arrow, this red angle I drew over here, okay? This is alpha. We want the bearing though, that's theta over here. So how do we get theta from alpha? Well, alpha plus theta is 90 degrees. So theta is just 90 minus alpha, which is 7.3, which matches our answer over here again. Okay? So hopefully just me explaining these two methods helps. If you find one more comfortable than the other, then by all means just use that one method you're more comfortable with. I'm definitely more comfortable with this method. It's more intuitive to me. You're just adding two vectors and all that. Versus here, you had to find angles and be able to, you have to draw your picture well to see that, you have congruent angles and all that, which can get confusing and get time consuming. And then if you make one small error there, then throws off all your calculations too, okay? So hopefully this was helpful. Hopefully this is interesting to if you learn one method or the other, like one method but not the other. This can maybe give you even more insight as to how vectors operate and all that. It is just triangles, but you can break down vectors into components too, and that's totally valid also. All right, so please give this video a like if it was helpful or even insightful to you, and please subscribe to the channel to look out for the next video. I don't know what I'm going to be doing, so please look out for that if you're interested.